In physics, power is defined as the work done divided by the time. How much work done in what amount of time? So the work is actually in joules, time in second, so the unit is really joules per second. James Watt actually did a lot of work on power, and we give it the unit W here for watt. So 1 joule per second is equal to 1 watt. That's why the light bulbs are in watts. 1 W. This is 100 watts, 50 watts, 75 watts. Now, sometimes we also measure power in horsepower. You and I, we have a pool filter, half a horsepower. So 1 horsepower, in case you're wondering what that is equivalent to 746 watts. That's the conversion factor. So let's see what's going to happen, how we're going to handle that here. You are in your car going, I don't know, pick a speed, not too fast. 5 miles per hour. For last miles, well, 5 miles per hour. Well, let's make it a bit bigger. 15. Nobody goes 5 miles per hour. How is that? 15. And there's a truck in front of you, and you're getting sick and tired of watching that truck going too slow. Now you step on the gas and you want to pass that truck. You go around them and you keep going. And now your speed, you're going 25 miles per hour. More reasonable numbers. And how long it took you to pass the truck? How many seconds? What's an average? 5 seconds? Unless you get a good car. It took you 5 seconds. If you get a 4-cylinder car, it's probably going to take you 5 seconds. It takes a while to get going there. The question is, that's your goal. You want to pass that car in 5 seconds. What is the minimum power required? To pass the car. How much power is required? We have to give you a mass for the car. Honda code, we said, let's say 1,000 kilogram again. See a Honda because that's what I have. So I know it's not a heavy car. Okay, well, to calculate the power, I'm going to leave a space there because I'm going to need it. To calculate the power is work divided by time. Well, I know the time. The time is 5 seconds. But what is the work? Do we know what that value is? Nobody knows what that value is. Can we calculate the work? Sure. We said work is change in kinetic energy, which is 1/2 mv final squared minus 1/2 mv initial squared. So it's 1/2. What's the mass? 1,000. Final velocity, which is what? I got to convert that from 25 miles per hour to meters per second. 25, you got to divide it by 2.24. It's 11.2 or 11.16 if you want to, meters per second. One half times 1,000. The initial velocity 15, let's divide it by 2.24. 6.70 meters per second. So 11.16 squared I got this number, the amount of work, to be 39828 joules. So how much power? 39828 divided by 5. And that's 7,966 watts. Now, if you want to know how many horsepower, remember 1 horsepower is equal to what? 746. So what is the power equal to in horsepower? We take 7,966 divided by 746, and that will tell us how many horsepower we need on that car. .7 horsepower to pass. Ten horses and 1 mule. A little bit less than a horse there. So 10.7 horsepower will get us actually to pass that car at that speed in 5 seconds. If I want to pass it in 2 seconds, that number will be larger. Let me do one more thing and we're done. The same topic with power. We said power is what? Work divided by time, right? And what is work? What's the equation for work? Work equals what? Well, beside that, force times what? Distance. I like force times distance over time. You're right. It's also changing kinetic energy, but I want that equation. And going back to chapter 2, maybe in the book, or what is distance divided by time? What is that labeled as? Distance over time. Speed. So power is also force times velocity or speed. So that's another way to get the power. If you don't have the work or the time, but you have the force and the velocity, you can get the power by just using force times velocity. If I go, actually, when we say velocity, we're talking about average velocity, really, because we're talking distance over time. That's average velocity. You know, so whatever your average velocity is. So if we go back to this car here, trying to pass, you know, we can calculate the force if we want to, because we know what the power is, right? We calculate that power. Power equals force times V average. We know for the car here, the power was 7966, right? I'm looking to see what is the average force here that was applied the whole time. Well, what is the average velocity? Isn't that 1/2 V final plus V initial? Isn't that what average velocity is? 1/2 V final plus V initial. What's V final here? The V final was 11.16. What was the V initial? 6.7. So we can calculate actually what the average force was applied here. So this will be 9.15 times F equals 7966 to get what the force is. (871 Newton). So during that time you're trying to pass, that was the force being applied on you with the average, with the value of that force. We said an average force of 871 Newton. And believe